Okay, today is Wednesday, October 10th, and this is the second of currently two lectures on SQL for IST 659 that normally meets on Mondays. The reason that I'm currently videoing this lecture is because of an illness that kept me out of class on Monday. So this is meant to provide the students with an opportunity to still learn the material from the professor, and also take it away offline so that when they're doing the labs and the homeworks, they'll be able to actually still reference the material with context. So for those of you who have not yet seen the first video lecture, which covers the material of what is SQL, both DDL, which is data definition language, and DML, which is data manipulation language. If you have not yet seen that lecture, I highly recommend you watch that video first, since it covers most of the topics and the instrumentals that we'll be executing today in Microsoft SQL Server. So yesterday we focused on how you can actually create tables, relate them, and constrain them using SQL, structured query language, which is a scripting programming language primarily used in relational database management systems. So today we're going to actually do a deep dive into how do we take an ERD diagram and actually create these new tables with constraints, with inserting data directly into the database. You're going to watch me do this live. Well, whenever you watch it, it will have been live by the time you see it. And I might fail and I might falter, but that's really what it means to program, and that's what it means to iterate through solutions. So the only thing that I've done beforehand is evaluate the actual ERD, but I want to show you a live demonstration of how you can actually implement these into tables in a database so that you see sort of why particular constraints are important, because I'm confident that I will violate them. So for instance, if I try to insert a new foreign key that doesn't exist in the primary table, there's going to be a problem. There's going to be a key constraint. So I'd like you to see me fail so that you can also learn to avoid those pitfalls. So today's session, as you can see on the screen, is focusing on converting this sort of rudimentary Twitter model into database tables. That's sort of the first goal. So I'm going to introduce you to an ERD that I developed, earlier today, which relates users, tweets, and sort of an associative entity called user tweets. We're going to take that ARD and kind of convert it into tables in the database. We're then going to take the primary key and foreign key constraints and implement them on the tables in the database. Once we've done that, we're going to insert data into the database and into the tables that we've created. Then we're going to use SQL, specifically the select SQL statements, in order to actually query information from these tables. Then we're going to decide that we don't want some of the records anymore, so we're going to drop the records. And then lastly, we're going to decide that we don't want some of the tables anymore, and we're going to delete the tables. So yesterday, if you recall, there's a difference between dropping records, which is a data manipulation action, and deleting tables. Oh, you know what? I got these wrong. If I could restart the video, I would, because this is a really bad mistake. There we go. Okay. So there's a big difference, and one that I didn't even get right just now, but there's a big difference between actually removing records from a table, which is known as deleting records. And then if you want to actually remove the table altogether from the database, you want to drop the table. So deleting is data manipulation, DML, and dropping is data definition, DDL. Okay. Cheat, you're the only one that knows I got that wrong. Everybody else will easily forget. Okay. So I might make this a little bit bigger because initially I had more text. So here's the ERD I've created, and it looks pretty simple, but has some hidden complexities. First of all, we have three primary entities, 2 strong and 1 weak. We have a strong user table, and the user table with a primary key of a handle. I believe that's what people call the I don't know, for me, it would probably be at Ben Nichols Professor. That would be my handle. Then we have the mandatory attribute of an email, the mandatory attribute of a member date, and that's the date that you start using Twitter. And then lastly, we have an optional attribute of date of birth. In terms of the data types, the handle and the email are both varchars, and we've made them length 150. And in addition, the member date and the date of birth are both date data types. The other strong entity that we're going to be modeling today is the tweet entity. Now, the tweet ID acts as the primary key, and in this regard, we're going to make it an auto-generated surrogate key. So in this way, we're going to use, if you recall from yesterday's lecture, we're going to use the identity function in order to identify tweets. And in addition, the other attributes for the tweet entity, we have the content. So this is the actual tweet that someone is sending. This is the message. And this has the data type of varchar, and specifically it has a length of 280, which is exactly the same length as the maximum allowable length of a tweet. In addition, we have tweet origin, and this is the original handler, or the original user, it's the original user's handle who first tweeted out the actual message. And again, this is a foreign key related back to user. Lastly, we have this notion of a retweet, and this is the number of times that someone has retweeted this particular message. For those of you who do not know, retweeting is the ability to post someone else's message through Twitter, and it's called a retweet. So here, retweets is going to act as a calculated attribute, which is an integer, and it's simply the number of times that that particular tweet has been tweeted by someone else. Now, lastly, we have an associative entity called user tweet. These are instances of a user sending a message to their followers. So here we have another surrogate key as the primary key, and we call it user tweet ID, and it's an integer. So again, we're going to use the identity function in SQL Server. Excuse me, I'm going to sneeze real quick. Nope, I did not sneeze. So my illness is not quite resolved yet, so I'm still working through that. In addition, each user tweet has two foreign keys. One relates to the user and one relates to the tweet entity. So the one that relates to the user is the foreign key handle, and handle is a required attribute or a mandatory attribute. And that's because you cannot have an instance of a user tweet without having had someone send it. Additionally, we also have tweet ID, and that's because you can't have sent a tweet without it existing in the tweet table. And then lastly, we have this retweet flag. This is going to be a single length character that will indicate whether or not this is the original instance of this tweet, or if it's this is an instance of the tweet having been retweeted. I know this is a lot of very domain-specific language, but if anyone has any questions about tweets and retweets, I'm happy to take it after this meeting or after this lecture. Okay, I'm going to take a quick 10-second break while I blow my nose, and I will be right back. Okay, I'm back. So now that we have this model in place, what are we going to do? How are we going to get this into the database? So what we're going to do is we're going to first, like we mentioned here, we're going to create these tables. Once the tables are created in the database, we're going to constrain the tables using the foreign key and primary key attributes that we've identified in the ERD. Next, we're going to insert new data into those tables. Now, this will be data that I create on the fly. I don't have it prepared, so it won't be very dense tables. It will be very sparse. In addition, once we have the tables, we'll query them using some simple select statements. Then we're going to delete records from those tables. We're going to say, you know what, I don't want that record in the table anymore, and we're going to delete it. And then lastly, we're going to drop tables. We're going to actually remove them altogether from the database. Okay. If this was regular class, I would ask if there are any questions, but I will move on appropriately. So we're going to jump into virtual lab. So I have already spun it up, but the way that I access SQL Server through SU's iSchool, I guess, platform is I actually launched an instance of Remote Lab. In Remote Lab, I'm able to use all of the programs available to you as SU students, specifically Visio and SQL Server. So today we're going to be using SQL Server as the primary database management system. So you can find SQL Server by either searching. So you could type SQL Server, if I could spell it right. There we go. SQL Server Management Studio 2014. This is the exact program that you should be using for the lab this week. So once you've opened it, it will ask you to connect to a particular database or not, a particular network instance. And that network instance should be IST dash, hold on, I need to look it up because I breezed through it too quickly last time. So it should be IST-S-students is the network that you should be connected to with respect to SQL Server. And if that's not available to you, just let me know and we can sort it out with IT. Let me see, actually, I'm gonna reopen SQL Server and maybe it will prompt me for that so we can actually demonstrate. Okay, so yes, the server name here will be IST, all lowercase, -S students. This is very important. And then you're going to use the regular Windows authentication in order to connect. So something about SQL Server is that SQL Server is actually something called a data warehouse. And a data warehouse is a collection of multiple databases that are all accessible from sort of a unified point of view. So the point of view here, you're using the SQL Server Management Studio. But what's unique about SQL Server is that you can create and query cross multiple databases. In many other environments, that's far less common. I have no interest in making Microsoft SQL Server any better, so I'm going to ignore that message. So here, I actually have the ability to see all of your databases, but it's going to automatically put you in the database that's relevant to you. If I can, I have too many windows open. So you'll notice, all right, so the first thing you're going to want to do in this environment, you want to hit New Query. New Query is going to open a window and automatically connect you to your default database. So here, my default database is IST659, our section number, which is M002, and then BW Nickel, which is my SU ID, or whatever SU calls their IDs. So that's my default database. And that's the database that you should be doing all of your work in. And once you've done your work, I can actually go in there and evaluate it and help you if you've gotten stuck. So it's important that you do it in that particular database relevant to you, the student. Okay, so the first thing that we wanted to do today was actually create tables. So if you remember from the lecture, there are particular SQL keywords that allow us to create tables using data definition language, DDL. So here we're going to actually we're gonna start typing away, and as a cheat, I'm actually going to have my slideshow up from yesterday in the event that I have forgotten the exact command as we go through. I shouldn't, but I might. So the first thing we want to do is we want to create tables. Now, yesterday we talked about the particular order that that tables should be created in order to avoid dependency conflicts. And by dependency conflicts, I'm talking about foreign key and primary key constraints. So, for instance, if you have a primary key in a table, you cannot have, you had to have loaded the other table first so that there's a particular value that's relevant in order to, I guess, maintain that foreign key, primary key constraint. So what we're going to do here is, in order to avoid that, we want to look for tables that don't have a foreign key already in place. So there's only one table that doesn't have a foreign key, and that's the user table. So logically, that's the first one we're going to create. So as a point of preference for me, I like to use all of I like to use all caps when typing in SQL keywords and commands. So here I just lied because my caps lock was off. So I'm going to type create table, and then I'm going to name that table user. However, I want user to be lowercase, and that's a matter of preference. However, I now realize that user is a keyword in SQL Server, and you can know that because it's bright blue. So in order to avoid that, I'm actually going to rename the table Twitter user. Sometimes you have to do things on the fly, and then I'm going to do that right now. Okay, I'm going to just give a line break. And now, if you recall, it's open parentheses, and then and then it will be a closed parentheses once you're done actually creating the table. So in this gap here, I'm actually going to identify the different attributes that I have in my ERD. Excuse me for 1 second. I'm going to sneeze. Okay, I'm back. So the first thing that we're going to input here is going to be handle. Pardon me, handle. Very good. And we're going to say that it's a varchar with a length of 150. And we're also going to cast it as the primary key. Now remember that each particular value that you're going to put into the attribute, each particular attribute that you're going to create for a table needs to be comma separated. So here I'm going to comma separate, and then I'm going to do email, which is also going to be a varchar. And it's also going to be length 150, and it's simply going to be unique. So remember yesterday there was a keyword called unique. This means that you cannot have multiple instances of this value, and it acts as a candidate key. So here we cannot have two Twitter users under the same email address. So we're making sure that here the email is unique for every instance of the Twitter user table. In addition, now we have member date. This is going to be the the data type of date, and it's going to be mandatory. So what we're going to do in order to do mandatory, we're going to actually make sure that it's not null. It's the same as mandatory. In addition, we're going to do that to the one above as well. We're going to also indicate that the email is not null. Okay. The next entity that we're going to create is, the next attribute of this entity that we're going to implement into the data table is date of birth. This is also going to be a data type, and it's not, it's optional. So actually, now that I remember, I made it optional in the RD, therefore it's allowed to be null. So we can just write no. So there's a question. Is there a required order of the keywords? There may be, and I don't know. So we're going to find out when we attempt to execute this command. It may throw an error, and I may have to switch the unique versus not null. And this is why I kind of wanted to do it live, to show you some of the pitfalls and sequences of things that I may not know off the top of my head. Okay, so we have all four of the attributes that we identified in our ERD, and we're going to try to create this table. So in order to execute a SQL command in SQL Server, there's something called execute. Or you can also type F5. But here I'm just going to click the button execute. Okay, so Chi doesn't look like it needed, doesn't look like it mattered. So I'm actually going to try it in both directions. So I'm going to drop the same table I just created. So I'm going to say drop table, drop table Twitter user. Okay, it's dropped. And now I'm going to change the order of unique and not null. Another fun thing about SQL is if you want to comment something out, there's two ways to do it. For a single line, if you just do dash dash, it will comment it out so that when you execute the full script, it will not execute this line. In addition, if you wanted to comment out a greater portion, like a block quote, it's backslash star, and then it's star backslash. And then this will all count again. Okay, so now I'm gonna actually try to see if the order mattered. So I'm gonna run it again, and it didn't. So Chi, to answer your question, the order does not matter in this case. So you can put unique before or after not null. Okay, so we have our first table created. And that was pretty easy, in my opinion. I hope that you all feel the same. So what's really common in scripting is to copy and paste. So I'm gonna go ahead and do that and simply change some of the informations so that it's much easier and quicker to type. So here we're gonna now create a new table called Twitter. And we're gonna actually have the first thing, which is tweet ID. And it's going to be an integer, which is just int, by the way, not full integer. And now we're going to implement something called, what is it called? It is called identity. I'm sorry, I'm just referring to the notes. It is called, I am struggling in the moment. Primary keys. Here it is. Okay, I was right. So it's called identity. So here we're going to indicate int. Sorry, my mouse has died. This is rather unfortunate. There it is. Oh, no, it has died again. This does it about 3 times a day. There it is. Come on back. All right, great. And we're back. So what we want to do here is we want to do all caps, and then we're going to do identity. And we're going to pass in, again, the first identity takes in 2 values. First, it's the first key that you want. So we're going to start with the first ID being 100, and then we're going to say increment by 1. So the first tweet will be 100, the second one will be 101, 102, 103, and so on. Additionally, we're going to identify this to be the primary key once again. The next thing that we're going to have is the content. And this will also be varchar, but we're going to make it much larger. We're going to make it 280 characters, which again, I think I mentioned this earlier, is the actual maximum length of a tweet. Now, you cannot, it in fact cannot be null, because otherwise you will never have actually created anything. I don't think you can tweet nothing. So let's say that the content has to have a value. And then in addition, we want to make sure that, no, it doesn't need to be unique either, because the content itself, you could tweet the same thing as another person, and that's perfectly valid in Twitter land. Next up, we have tweet origin. And for me, I define this as the actual original tweeter of the tweet. So it's the original handle. So this is actually going to be the foreign key. And I'm going to show you how once you set up the table, you can actually constrain using foreign keys. We're going to make this not null because every tweet had to have had a first person tweet it. And then lastly, we're going to have another field, which is going to be a calculated field of retweet. And it's going to be an integer. And it can be null. It's allowed to be null. Because maybe a tweet has never been retweeted. Therefore, this would be either 0 or have no value. Okay. Next up, we're going to actually now constrain this. So what we're going to do is actually implement a foreign key constraint by doing the following. We're going to say constrain, or is it, no, it's constraint. Should have an S in there. There it is. Now we're going to create an object that acts as the foreign key object. So this will be constraint Twitter. And there's only one foreign key, so I'm just going to call it Twitter underscore FK. And then I'm going to say foreign key. And I'm going to pass in the foreign key the actual key for which will be referenced in the other table. So it'll be retweet. No, it'll be tweet origin. And then it's going to be references. And then we're going to pass it the origin table that we're referring to. So here, that would be Twitter user. And we're going to pass in handle, because that is the unique ID for the original Twitter user that first tweeted that particular message. Okay. So one thing to know about SQL Server is if I run this whole thing, it's going to try to actually execute the already existent Twitter user table. So watch. It's going to. Oh, interesting. Yes. So it says, oh, Twitter user already exists in the database, and that's perfectly fine. And it's just indicating that you've already created the table. So this has now been ignored and threw an error. But we can now see that both of these tables exist, because if you select from, let's say, Twitter user, it should return an empty table, but one that exists. There you go. So you'll see down here, it returned the table which has no data. And similarly, if you want to do it for Twitter, you do it here as well. Aha. Okay, so Twitter was never created, and that's because when SQL Server attempts to execute, it failed because this table already existed. So what you want to do is you want to just highlight with your cursor the block that you want to execute, and that will avoid the problem of hitting things that have already been created and throwing errors. So now if I execute this selected statement, that will execute without a problem, because we're not executing the area above. We're only executing things that have been highlighted. And now if I want to select star from Twitter, you'll see now I have an empty table associated with Twitter. Great. And we have one more table to create. And that will be the user tweet. Okay. Now, because we're using a surrogate key, we can continue to put the primary key up here, but just for demonstrative purposes, I'm going to actually create the primary key as a constraint down below. So remember, this is an alternative way to create the primary key, but if you're going to do it this way, you do have to indicate that it's a not null value. So the key here is going to be user tweet ID. So user tweet ID. It's going to be an int, and it's also going to be an identity. And let's say that this starts from 1,000 instead of 100. And I think it's going to confuse me later, but that's okay. Actually, let's have it start from 1. The next thing then we have is handle. So this is the next attribute that we want to relate into the database. So handle will be a varchar 150 length characters. Similarly, not null. You notice that these are both mandatory attributes in the ERD. Next up, we have tweet ID. This is also not null, and it's also going to be the foreign key, which relates the user tweet to the tweet table. And then lastly, we have a retweet flag, which is going to be a char 1. So it's going to be a single length character, but it's going to be allowable to be null. So effectively, actually, no, you know what? Let's make it not null. Let's make it mandatory. Do I want to make it mandatory? Now I'm thinking whether or not I want it to be mandatory, and I do. Everything is either a retweet or it's not. So I think that's perfectly fine. Okay. Next up, we have you know, I don't have the date of the tweet. Let me add that. It's not in the ERD, but I want to do, let's call it date time. Tweet. Let's call it tweet timestamp. And it's going to be a date time. And it's going to be not null. And it's also going to have a default value. So if you remember from the lecture yesterday, you can set particular things to have default values. And what that does is if you don't actually inject new data into the database for that value, it'll automatically select the value for you based on some operation that you've already designed. So yesterday, the example was actually inserting dates because of the default value. And I want to do the exact same thing here. I'm just looking back in the notes to how to actually implement that exactly. So bear with me for a quick second. I want to implement this correctly the first time. Aha, here it is. So it's date time, and then it's default. And the function is getDate. Great. Now note that because there's a default value, it's never going to be null. So you do not have to indicate both with a default value. You don't have to indicate whether or not you want it to be mandatory or non-mandatory. It's always going to have a value, since if you don't pass it one, it will automatically create one for you. Therefore, there will never be null. So you don't have to indicate its minimum cardinality here. Okay, so these are the different, these are all of the attributes for the user tweet table. And now we're going to constrain it. So first, we want to actually apply the primary key. So we'll call it Twitter PK. We're going to change this to primary key. We're going to say that the user tweet ID is the primary key, and it doesn't need to reference anything. That's all the statement needs is right there. It's just simply the primary key and the field that it's being cast. Next up, we want to constrain a foreign key. So we're going to do FK, but then because we have multiple foreign keys, we actually want to indicate which one we want. So this will be FK user. And the primary key here, I'm sorry, the foreign key here will be the handle. In addition, we have the other foreign key, which is FK tweet. And the foreign key here will be tweet ID. Now remember that we also need to have it reference some table. If I could spell reference. There it is, references. So what is it referencing? This, the user is referencing the, I think it's Twitter user. And then we're going to pass it handle. Let's recall, yep, Twitter user, and it's called handle. And then in addition, the other foreign key constraint is going to reference the tweet table, and this is going to be tweet ID, I believe is what I called it. Oh, it's the, oh, why did I call it the Twitter table? That was not very intelligent to me, but I guess we'll stick with it. So it'll be the Twitter table, and it'll be a tweet ID. And then this last comma does not need to be there. Okay, so let's see if we've done this correctly. So again, we highlight the section that we want to execute, and then we hit execute. Okay. So we have our first error message. Bear with me, I'm going to mute while I read it. Okay, this is great. So it actually looks like we have our first problem. And this is great because it's something I mentioned in lecture yesterday. You really want to make sure that you have both the data types of the referencing column and the foreign key column to be the same. So here, I noted that this is wrong. So this should be tweet ID. And then additionally, we want to make sure that tweet ID, oh, I had it wrong here too. So tweet ID here is a varchar 150. And let's make sure that it's also, oh, it's an int up here. So we want to make sure that that is the same in both places. This was a good check. All right, so let's see if we fixed the problem. Amazing, okay. And lastly, we're gonna check to see if the table exists. So we're gonna select star from, was it user tweet? Yeah. Okay. Oop. All right, so we've successfully created the 3 tables associated with our ERD. So this is, for me, kind of the most difficult aspect of this, making sure that you've created the tables, you've referenced the different primary keys and foreign keys. Now the next phase of this will be actually inputting data. So as you recall, the first step today was convert the Twitter model into a database and enforce primary key and foreign key integrity. So we've done the first 2. The next thing that we want to do is insert data. Okay, so how do we insert data, and how do we make sure that we create data that is intelligible and doesn't violate the constraints? So if you'll recall from yesterday, the command to put data into a table is called insert. So we're going to type that first, insert. Now there were 2 ways to actually insert data. The first way assumes that you memorized the column order and you simply inserted values into the table, which is fine, except that if you didn't remember the order, either it will throw an error that indicates that the data is not of the right type, or you've actually just put the data in the wrong columns, which could lead to bad decision making if this was a decision making table. So what we're going to do today is we're instead going to actually articulate which columns we're inserting this data into. So what we do first is we say insert, and then the next keyword is into, and we're going to first insert data into the strong entities. And that's because for the foreign keys, we want to make sure that all of the data is persistent in order not to break those constraints. So since there are no constraints on the user table, since it's a strong entity, and then we'll go from there. So there's been a request that we look at the Twitter table. Can we click into the table and see what it looks like? What does that mean? I'm sorry. Like in the left-hand panel over here? Is this the right database? Bear with me for a quick second. IST 659, M002, BW nickel. Yeah, here we go. Okay, so here, the request was can we look at the metadata for the table using the Object Explorer in SQL Server? So you'll notice here are the 3 tables that I've created in my IST 659 M002 BW nickel database. This is a database. This is what each one of these are all databases. So in the database, there are many things that you can look at. The diagram, I don't think I actually want to look at that. The tables that we've created. So here we have 3. So we have the Twitter table, the Twitter user table, and the user tweet table. So in the Twitter table, we have the tweet ID, we have the content, which again is the message. And remember, it also has the data type and the constraint on that. So we have the not null constraint on the tweet ID, we have the not null constraint on the content, we have the foreign key constraint on the tweet origin, and then we also allow the retweet integer value to be null. In addition, we have the tweet user. You see the columns here. We have the handle, and you notice the key indicates it's the primary key, so the handle is the primary key. We have email, which is not null, member date, not null, and date of birth, which is null. Remember, date and date are both date type formats as well. Okay, so those are the 3 tables. Oh, and user tweet, sorry. User tweet has user tweet ID as the primary key, handle and tweet ID as the pair of foreign keys. We have the retweet flag and the tweet timestamp. Okay, Chi, do you have any other questions about the metadata in the Object Explorer? Okay, take that as a no. I'm going to hide that pane for a moment, and we're going to go back to inserting data into, again, the strong entity of user. So we're going to insert into user. We're going to indicate the columns. So the columns for user will be handle, email, and date of birth. So I'm actually going to copy these over because, again, oh no, I did this before. Sorry about that. I'm lazy, so I'm going to do the following. I'm going to do that. I'm going to do that. And I'm going to do that. Chi, I do not know why your tables didn't show up, but after I'm done recording this lecture, we can take a look. Oh, I may know, actually. So sometimes you may not see your tables immediately. What you can do is close, scroll all the way to the top, select the data warehouse, which is the top element. You right-click, and you go to refresh. So sometimes when you create things, you need to refresh the metadata that's rendered in the this is called the graphical user interface. Cool. So again, we're going to insert into user. We're indicating explicitly which columns we're inserting, and then we're going to actually pass it data. So we're going to do the following. We're going to say values. All right, so let's think of a couple handles, right? So 1, 2, 3, 4. Member date. So these are 2 actual dates. So what you have to do here, because what you're doing here is you're passing in string values. So you actually need to cast these as date. So we'll do the following. We're going to say cast as date. And we're going to do cast as date. So the first value, let's do, I'll do my handle, which is, let's call it BW Nick Prof. My email will then be, let's say, ben@su.com. We're then going to say the date that I started Twitter was 2018, 01/01. Maybe I started this January. This is the common date syntax for SQL. It's 4-point year, so it's year, dash, month, dash, day. That's the common SQL format for querying and inputting dates. We're going to actually then use this function called cast, because if you just say that here is the date, this is actually not the date object. This is simply the string that indicates the date. And the SQL function cast will take this date and cast it into the date format. And similarly, we want the same to happen here. So we're going to say the date that as my date of birth. So let's say it's hold on, my date of birth. Let's do 1985. 01/01. It's not my birthday, but I'm putting it here. Okay, so let's see if we can insert this into the database. Nope, didn't like something. So, first of all, that's not the name of my table. So that's a good catch, right? It's Twitter user is the name of the table. Let's try this again. Nice. So now I've actually inserted a piece of data into my table. So let's check if it's there, right? Select star. So again, select all columns from Twitter user. I had it in my clipboard. Hey, so there's my handle, there's my email address, the date that I started, and my date of birth. Now let me actually see if I could have run this same command without having cast those dates. I'm curious. I don't think it would work. So let's see if I change it slightly. So BW Nick Prof 2, let's say it's Ben 2, and I don't cast these. Instead, I just say that they are strings. I wonder if it will automatically cast them. Okay. We're going to highlight this row. I'm going to try to highlight this row. There we go. Oh, it did work. Okay, so it automatically casts them. So this whole casting mechanism was unnecessary. It was a bit of a shot in the dark, but if you pass it a string in the proper format, it will automatically cast it as a date. So that's good to know. Okay, so now we have two records in the database. Let's add a few more. Chi, since you're on the call with me, I'm going to use you as a guinea pig. So let's say that your handle is at Chi1. I'm going to say that you are Chi at SU.com. Let's say that you've been on Twitter since 2015, March or May. Oh, my goodness. Since May 1st. And let's say that your birthday is 1992, 0501. We shall insert that into the database. All right, let's see if it's there. Success. We see Chi's handle and email now successfully in the database. So this is how you populate a table. I mean, this might seem really tedious, but if you have an interface with SQL that's automatically generating this, all you need to do is script these very standard templated commands, and then just input the new data fields in a particular column order. So we're going to do we'll probably do 5 more, and we have a good set of data, and then I'll execute them all at once. So 1, 2, 3, 4, 5. Let's do I don't know, Dr. Dog. Let's do Dr. Dog at, I don't know, dogu.com. Let's say that they've been on Twitter since 2014, and their birthday is 1902. Let's see. Chi, do you want to type me a Twitter handle to populate some data? Okay, he does not. Twitter scientist, data scientist, we'll call him DS at SU.com. We'll say that he joined Twitter in May of this year, and his birthday is, I don't know, 1991, 0101. Okay, that's a good one. We're going to do IST 659. IST 659 as a handle for the class. We're going to say IST, oh, I skipped one, that's why. Okay, we're going to do, oh, you know what, actually this reminds me that I should test the primary key constraints, but we'll get there. So IST 659, we'll do IST 659 at SU.com, and we'll keep the same birth date. And then we'll do one more, and we'll do, let's see, Ninja, who's the guy that plays Fortnite, right? Ninja. We'll do Ninja 1515 at, I don't know, Fortnite. Is it Fortnite? I don't know enough about this stuff. And maybe he joined Twitter in 2016 in November or in September. And then lastly, his birthday is 1955. He's an old ninja. Okay, so I'm going to take this one and pull it out and I'll show you why. So we're going to insert this data, and we shouldn't have a problem. Great. 4 rows successfully inserted. Now I'm going to try to insert a row that we already have in there, and hopefully it will throw an error because it's going to have a primary key constraint issue. Boom. Violation of primary key constraint. So we already had at Chi1 as a unique primary key. So we couldn't insert this new object in there simply because it would violate the key constraint. So that was a good test of whether or not the primary key function is holding. Try to insert something with the same ID as something else, and it should violate the key constraint. So let's take a look to see if we have all of our users. We do. So we have our handles, we have our emails, we have our member dates. Let's think of a quick query, right? Like, let's say, give me all users that have member dates from 2018, right? So we're going to say select star from Twitter user where member date is greater than or equal to 2018 01 01 0101. So how many records do we have now? We have 7. And how many of those joined in 2018? 3 of them. 1, 2, and 3. All of the other ones did not join in 2018. So let's see what happens when we filter for those 3. Great. So we see that by filtering on member date greater than or equal to 2018 01 01, we're only rendering the 3 that joined this year. So this was an example of the select clause in SQL. We're going to do more of this once we have the other tables, but I just wanted to kind of give you a quick glimpse of how this would look. Okay. Next up, we're going to insert into the other 2 tables. So I'm going to copy the insert command because, again, I am lazy and don't want to retype it. Okay, so now we have the insert into the next table that is dependent only on user is the tweet table. So we're going to insert into tweet. However, I didn't call it tweet. I called it Twitter, which was my mistake. So we're inserting into the Twitter table. We have tweet ID. However, we don't actually have to put anything in tweet ID because it's automatically generated. If you'll recall, it uses the identity function and increments by 1, or increments by 10, I think, actually, the way that I set it up. So this is a good test of that. Next up, we have the content, and this will be the message that we're going to tweet out to our followers. Pardon me, I'm going to blow my nose really quick. Okay, I'm back. So we have the content, we have the tweet origin. Oh. Tweet origin, and we have the number of retweets. But the number of retweets is a calculated field, so we're actually not going to put anything in there yet. So here we only actually have to insert 2 things, the content and the tweet origin. So here we're going to knock it down to 2. Okay, so let's say the first message that I'm going to tweet is I love IST 659 so much it hurts. That's our first tweet, and it was made by, let's say it was made by, well, you know what would actually be helpful if I can see all of the users down here while I'm typing this. So I'm going to do select star from this was a tweet users, what did I call this? Twitter users? Yeah, Twitter user. Okay, so here are all of our handles. So let's say Dr. Dog is actually making this one. So you can copy right from this table, and I'm going to input it here. This is sort of just a shortcut when we're doing this. So let's check. Very good. And let's prove that it's in there. So select star from Twitter. Oop. Great. Okay, this is awesome. So first you see the message that we put here. We have the tweet ID of 100, which was the first value that we indicated here. This is very small, sorry. Okay, so we have the identity here, the tweet ID, and we're saying start at 100 and increment by 1. So the next user that the next tweet that we implement will be incremented by 1. Great, this is really good. Okay, next up, we are going to do a couple of more of these. Oh, sorry, my mouse likes to make this larger and smaller. Oh, I don't want the space. So let's see what happens if we try to implement something with that doesn't exist yet, right? So maybe the handle is at doesn't exist. So let's say violator. So if we try to run this right now, we should get an error. Great. Because it conflicts with the foreign key constraint on the Twitter foreign key object. So there is no handle yet called doesn't exist. So until we actually load that to the database, until we load that to the users table, the Twitter users table, this cannot be inserted into the Twitter table. So I'm going to delete this one out. Let's say oh, that's a bad example. So there are particular things that you cannot do in SQL, like single quotes. The way that you escape them, I believe, is to do it twice. So I'm hungry is another tweet that someone made. I'm hangry. How about that? It's hungry and angry at the same time. And maybe the person that did this is, oh no, Twitter user. Oh, it's up here. That's why. Okay, so the user that did this maybe is @ninja. So @ninja is hangry. Oh no, I'm sorry, it's here. Okay, so now it's in the database, and let's check. Oh, that's the wrong one because I undid it. There we go. Great, I'm hangry @ninja. Now note that these are both null. These are something that we're going to address later on in this lecture. And let's do maybe 2 more. So let's say, I don't know, can't wait for Game of Thrones. A lot of contractions in my examples. And this will be maybe tweeted by @Chi1. Chi, I don't know if you like Game of Thrones, but in this example, you can't wait for it. Okay, and let's do one more example. Please stop using me as an example. Also by Chi. Great, okay. So now let's look at all of those records in the Twitter table. Okay, so now we have 4 tweets that have all happened, and we have the tweet origin. Now what we're going to do is we're going to look at the user tweet table, and we need to be very delicate about what we insert into the user tweet table because of not only the primary key constraint, but also the foreign key constraints as well. So we're going to lastly insert data into this table. So this table is again called the user tweet. Great. And note that the user tweet again was an auto-generated key, so we do not need to actually pass a value in for it. Handle we do, so we need to say handle. In addition, we need tweet ID. And we also need the retweet flag. However, we allowed that to be null, so we can optionally pass that or not. Let's say that we do, right? Retweet flag. All right, I'm going to make this a little bit bigger. I'm going to try to make this a little bit bigger. Okay. Great. I think we have the ERD down at this point. Okay, so let's see. The handle might be at Dr. Dog. The original message is I'm hungry. Oh, I'm sorry. The tweet ID, we do not know. So we're going to actually have to look that up, right? Select star from Twitter. Oh, and my mouse died again. That's fantastic. There it is. Okay. Great. So the tweet IDs are here. So let's say that Dr. Dog is tweeting the tweet ID number 100, which is here, which is the same thing that he already tweeted. So here we know that this is it a retweet, yes or no? We're going to say no. Now, for the other two, or the other ones, we're not going to actually indicate any constraint on the retweeting, and we'll do it later. Okay, so then let's do Ninja is going to retweet, let's say, 103. Let's say at Chi1 is going to retweet tweet number, I don't know, 102 to make Ninja happy. And then lastly, let's have somebody that hasn't tweeted anything retweet something. So I'll retweet also Game of Thrones. (103). Okay, we're going to insert these into the database. Oh, cool. What do we have? Cannot insert the value null. All right, looks like I made this a mandatory field. So I believe the rest of these are all yeses, that they are retweets. Great. Okay, boom. And then let's check if we have data in the database. Select star from, what did I call this? User tweet. Great. Okay, amazing. So here we go. The first thing that we have here is we have user tweet ID, and this is something that was automatically generated. Remember that we use the identity function again, and we are incrementing by 1. However, I am a little curious to know why I went from 1 to 5 to 6 to 7 to 8. Oh, now I know. So it actually incremented. String or binary data would be truncated. Chi, what do you mean by that question? Or statement? Okay. So you got your own error. Again, we will address any of your errors after we're done recording the lecture. So I realize now, though, that while we got the error, it incremented the counter of the user tweet ID error ID. It incremented them by 4. Even though it tried to insert them, it errored and it said you need to have a value for retweet flag. But then when I actually inserted new values, it successfully inserted them, but the counter was already at 5 instead of back at 2. So if you fail to insert something and it's auto-generating, you're going to actually have offsets on the the identity function when it creates these keys. I'm sure there's a way to fix this, but this is a little quirk that I've never noticed before. So 1, 5, 6, 7, 8. Since they're all keys, this doesn't break the workflow at all because you're still incrementing as you go up. But otherwise, this is interesting. Okay, so now that we have data in the table, right? Maybe we want to learn something. Maybe we want to I guess, know a fact about some of this data, right? So let's say, how many tweets has Dr. Dog had? So maybe we want to know, let's do select star from user tweet where handle is equal to Dr. Dog. Why I'm saying Dr. Dog, I don't know. It just sort of popped in my head. So Dr. Dog has tweeted twice. Both of them were original tweets, or retweet equals no. However, if we also want to know which tweets that Dr. Dog didn't make, you do not equals to. So here are all the tweets that were made not by Dr. Dog. So Professor Nichols made one, Chi made one, and Ninja made one. And you can see the timestamp of when they were made. Now, let's see if, for instance, there is a tweet by Dr. Dog that's not a retweet. And retweet flag is equal to yes. So let's see if Dr. Dog retweeted. He did not, even though I'm confident that one of the tweets is a retweet. I'm pretty sure tweet number 100. This is an interesting case. I realize now that I've actually had Dr. Dog tweet number 100 twice. So there's no constraint on the uniqueness of the combination of Dr. Dog and tweet ID. And I guess this is sort of a nuance of having surrogate keys. You can have the combination of a user and a tweet happen more than once. It's not a distinct combination of Dr. Dog and tweet ID. So perhaps if we never wanted the same person to tweet multiple times on the same thing, you should put that constraint in there. However, as far as I understand, Twitter allows you to tweet the same thing over and over again. So this is actually not per se. Oh, I guess it is a problem. I wonder if you can retweet the same message multiple times. I don't know. I don't know the answer to that, to be honest with you. Okay. Well, great. So let's assume that this second one here is actually a retweet of his original message. Let's say that you can retweet the same message multiple times. So let's do the following. Let's say that we want to actually update a value. And this is something that we were focused on in lecture yesterday. So let's say that we want to update the retweet flag. So we're going to say update the user tweet table. So remember, we want to update this to be a yes. So we're going to say update user tweet. We're going to set retweet flag equal to yes, where user tweet ID is equal to 5. And this is an integer. So we've identified this row. Since this row is uniquely identified by the user tweet ID is the primary key, we're going to say update the user tweet, the retweet flag to be yes, where the user tweet ID is equal to 5. Now, if we select all again, now we have, where this was rendering 0, we now have the fact that Dr. Dog retweeted the same, his own tweet. So now this is actually a yes value. And if we do select star from user tweet, we'll see now that there's only one original tweet in this message chain. Okay, so now we've covered how to update something. Let's see, how do we delete something? Maybe we want to delete all instances of Dr. Dog from the tweet table. Now remember, deleting data has implications on foreign key, primary key constraints. So if you delete data from the primary key table first, it will break the foreign key value that still persists in the weak entity. So what we want to do here is we want to delete something. We need to delete the data first from the weak entities of user tweet, then user. So let's say that we want to remove Dr. Dog from all content. We want to just get rid of that user right out of Twitter. We kicked them out of Twitter. So we're going to do delete. I'm sorry. We're going to delete, if I can type it. One moment. So it's delete from. We're going to, again, start with the weak entity, user tweet. So delete from user tweet. And then we're going to indicate what's the criteria that we want to delete. So delete from user tweet where handle is equal to Dr. Dog. Whew. Okay, so we deleted Dr. Dog from the user tweet table. Now if we select again from the user tweet table, you'll notice that the entries for Dr. Dog are gone. He no longer, that user doesn't have any actual tweet messages in there. Now let's see if we can delete him directly from the user table. I don't recall if there are tweets that are affiliated with him already, so let's first check that. Select star from Twitter. Dr. Dog does have an instance. So let's see what happens if we try to immediately delete him from the user table. We should get an error. Twitter user, I think was the name of the table. Yeah. All right. Cannot do it because it's a primary key, foreign key constraint on the tweet table. So we first have to delete him from the tweet table. We're going to keep this here, and we're going to do tweet. And it's no longer called handle. In here, it's actually called tweet origin. Well, it should be called tweet origin. Oh, it's because it's called the Twitter table. Execute, great. Now we're going to try that same statement that just failed moments ago. All right, and it succeeded successfully. So now if we check the other two tables, we should see that Dr. Dog has been removed from both of them. Okay, no Dr. Dogs, and then let's check the Twitter user. No Dr. Dog. We've successfully removed him from all of the tables. And notice that this order mattered. We first had to delete him from the weakest entity, then the weak entity, and then the strong entity. Okay, let's see what else we want to do now. So we've queried the data, we've deleted the records, and now we want to drop the table. So again, dropping tables have the same implication as creating them. So you need to drop them in the order of weakest to strongest, because when you created them, you went from strongest to weakest. So here, if we want to drop an entire table, we want to say drop table. We're going to indicate table because this is data definition language. So data drop table, and we're going to say user tweet, execute. Okay, we've successfully dropped that table. Now if I go to try to select star from user tweet, there's nothing there, doesn't exist. It's been removed from the database. Now what happens if I try to drop table user, Twitter user, sorry. I can't do it because it's referenced by a foreign key constraint. So the fact that this is constrained within the tweet entity or tweet table here based on this foreign key constraint, I cannot delete it. So I instead have to drop the Twitter table first. Oh no. Oh, I deleted it twice. I dropped it twice, I mean. So it's no longer there. So if I query for it now, select star from Twitter. It does not exist, but the Twitter user does. Okay, that still exists. I dropped it, and it's gone. So all of the hard work we just did has vanished. It's kaput. Nothing left. So that's it. That's really all this is about. It's about creating tables, establishing key constraints, inserting data, querying data, deleting data, dropping tables. So like addition and subtraction, multiplication, division, we have create and drop, which are inverse relationships. We have insert and delete, which are inverse relationships. And then we have select, which is like, I guess, the logarithm of operations. Okay, so there's nothing else I wanted to cover today. I believe everything that's required of you in the lab has been, so she is asking me to show the update statement, but I did go through an instance of updating based on the criteria user tweet ID equals 5. And since I have no tables left, I don't know that I want to go back through it. And if anyone has additional questions about updating data, I'm happy to do that separately. Okay. In addition, I'm going to post this video again tonight. And for anyone that needs additional assistance, I'm going to try to figure out if I can be on campus either Thursday night or Friday night of this week. Great. I hope that you watched this video and that this was helpful in progressing in this material. I will see you all next week. Thank you.